In this video, I will discuss Newton's second law and how we can use it to see how the motion changes when you know the interactions and vice versa. Newton's second law is telling us that the net force, which is related to the interactions of the system, is equal to the change in the momentum over the change in time. Now, because this number delta t is always a positive number, the net force and the change in the momentum of the system always point in the same direction. So because delta t is always positive, we know that the net force will be in the same direction as the change in momentum. So what I wanted to say here, they are pointing in the same direction. So this vector points in the same direction as the change in the momentum of the system. Now let's say, for example, that we have an object that is moving, let's say, in this path. And let's say that I want to find at this point over here, I want to find the direction of the net force. Is the net force 0 or is it not 0? If we take the simple case where the object is moving at a constant speed, so we have a constant speed, then what we need to do is to draw the momentum vectors right before and right after this point. So for example, right here, the momentum vector, I know it will be tangent to the path because momentum points in the same direction as velocity, and velocity is always tangent to the path. So right here, the P initial would be a vector like this one. And then to draw the momentum vector right after the point that I need to where I need to find the net force, the momentum final is going to be again tangent to the path, and it will be the same length since the speed is the same. This is P final. Now what I need to do is use these two vectors to find the change in momentum. So to make this figure a little bit easier, I will redraw and perhaps change the scale a little bit, the two momentum vectors. So roughly these are my initial and final momentum vectors, and I moved them so that they have the same tail. Now since this is P initial, the initial momentum, and this is the P final, I can find the change in momentum by thinking, okay, if this is the initial, what do I need to add to this one in order to get to the final? I need to add this vector. So this will be my change in momentum. Since the change in momentum is not 0 and it's pointing in this direction, then from Newton's second law I know that there is a net force exerted on the object at this point. And I know that roughly this is the direction of the net force. So anytime you have the path and you have knowledge about the speed or the velocity of the object, then draw the momentum arrows right before and right after, find the change in momentum, and the direction of delta P will also tell you the direction of F net. If the change in momentum ends up being 0, then of course you can see that your net force is 0. Now, momentum is not the only way to do it. You can also use velocity instead of momentum initial and momentum final. You could, since we know that momentum is approximately mass times velocity for very small speeds, we know that, let's say this is equation 1, this is 2, this is 3. If we combine 1 and 2, what we get is that the net force acting on a system will be roughly the mass of the system times the change in velocity over the change in time. So since momentum is mass times velocity, if you plug it in here and use a constant mass, then you have m delta v over delta t. So you could do the same process as I did here with momentum. You can do the same thing with velocity. Remember, momentum and velocity point in the same direction, so you will end up getting the same result. Either way of thinking about the problem is fine. Now we can also do the opposite process. So, for example, let's say I know that at this point in space I have a momentum that points this way. And then I am told that there is a force that is acting, a net force that is acting in this direction on the system. Is it possible to obtain an estimate for the final momentum of the system, where the object will be after some time? So, according to Newton's second law, the net force and the change in momentum point in the same direction. So, if this is the direction of F net, then I know that this is also the direction of the change in the momentum. Now, if this is P initial, I can draw P initial here. So this is my P initial. Now P initial plus the change in momentum will give me the P final vector. So with this process, using the net force to think about the change in momentum, and then using the initial momentum and the change in momentum, I can find the final momentum. Knowing the net force allows me to obtain information about the final momentum, about the final position also. So using the interactions, I can predict the motion using this process.